So last day uh, we ended our discussion on the k-fold cross validation part. We have seen what exactly k-fold cross validation is. We have also seen the examples and also went through a very simple code for creating the k-fold cross validation from scratch, right? So till date, the program that we have written mostly are from scratch, but fortunately, as a programmer, you have some very interesting packages in Python by which you can create the models as per your choice. So we will start with understanding the packages first. For example, today we will go through a package, a very vital package that mostly we are going to use in future. The name of the package is Keras. Okay, so let's start with this. Yes. So what is Keras? As it is written that Keras is an open source deep learning library written in Python. See, the library word is basically a similar synonym to package in Python. What basically library means? Library means that it has a lot of different function which you can use as per your choice. Just like you can say header files in C language. Similarly, over here you can just, if you just try to understand, try to map the usability of Keras in Python, you can assume this Keras is something like a header file compared to just analogous to the C language. Now in C language, if you include a header file, what you can do in that case, you can basically use all the function which is present within the header files. You can simply call the functions giving appropriate parameters, and you will get certain output from the function itself, right? You don't need to write the entire code. You just call the functions accordingly. In the same way, we also have lot of packages here, because we know it's a very usability of Python language is that there is a lot of open source packages which we can simply install by pip command, and then we can utilize the functions. So Keras is one of the most important package that we are going to explore for writing or developing the different machine learning models in future. Okay, so anyway, so as it is written that it provides a high level interface for building and training neural networks, just what I have said. And Keras acts as a front end popular deep learning framework like TensorFlow and Theano. See, this TensorFlow and Theano is also some package names which actually does the similar kind of job. Okay, for creating or training, I mean, different models, not only neural network based model, any AI based model, like all the different machine learning models that we have already seen, including your linear regression, support vector machine, random forest, decision tree, and many more. And also in future, we will learn different deep learning based models, like for example, uh, autoencoder, convolutional neural network, recurrent neural network. So those we will see, but not definitely in current days, we will see in future. So all these models we can easily build and train using some functions written in Keras package. Okay, so it's as a programmer, it's a you know now it will be a bit easier for you to create models. You don't need to write it from scratch. You don't need to explicitly write the algorithms from scratch. What basically you will do, you will simply call the function, and the function will do the same thing on behalf of you. So the next point is its user friendliness. Like since now basically you are the user of this Keras package, so you are not going to write the say for example back propagation algorithm. You will call a function. That function itself will do the execute the back propagation algorithm on behalf of you. Okay, and to call the function, definitely you have to pass some parameters, right? And that's already defined within the package itself, that these are the set of parameters that you have to pass if you want to call this function, which basically is going to do the back propagation algorithm and train the model, something like that. And with respect to Keras, it is very easy for the beginners to create the models, especially neural network based model. Okay, so that's why we are going to explore this. And also it's this Keras is actually gaining lot of popularity compared to the other packages like TensorFlow and Theano. So that's why most of the things you will see that lot of people uses Keras package. And actually this Keras package is given, is written on the top of the TensorFlow package. What I mean to say is that ultimately at the end, what basically all these packages are doing, creating some models. So Keras is also creating some models, TensorFlow is also creating some model. And what will be the difference? The difference will be with respect to their maybe the coding style or using the functions. So if you compare the Keras and TensorFlow, we will see that writing code in Keras using Keras package is much easier or user friendly more than the TensorFlow package. So that's why also we are going to use this Keras package. Okay. So just like what basically we have said that Keras basically provides very straightforward API. API means application programming interface. So it means that it's given application programming interface is not a very big thing. It's basically nothing but it's a a black box, you can say, a black box which will have some input that basically you are going to give, and the black box will do the things for you. For example, it provides a black box for creating models. So you will basically specify that with respect to multi-layer perceptron, if I say that maybe you will specify that how many layers you want in the model, how many neurons will be there in each and every layers. Okay, and what type of learning algorithm you want to implement over there, what type of optimizer basically you want to implement in the backpropagation algorithm, what should be the learning rate. So all these parameters you are going to fit within this black box, and this black box will basically do the consolidated whole things and create the model for you. So it's very easy for you now, right? So let's see, let's just what I was saying, that Keras is basically on the top of TensorFlow, and that is actually written over here. You see, if you see here, it is written that backends is TensorFlow and Theano. So Keras is compatible with both TensorFlow and Theano. So what does it mean? Why backend means like you are writing code in, maybe writing code for Keras, but Keras is basically use some part of TensorFlow. So you don't need to write the code in TensorFlow. You can write in Keras, and Keras will connect with TensorFlow automatically and do the same thing for you. Okay. Okay. So let's move. So I've just written a very small piece of code for you to understand what basically we're going to do. Okay. Like say for example, the first thing that we have, okay, using Keras is what I can say sequential API. What is this? A sequential API is the simplest way to build a neural network in Keras. Okay. And what is basically represents? It basically represents a linear, a stack of linear layers. For example, if you want to create a multi-layer perceptron having three layers, means one input layer, one hidden layer and one output layer, something like that. Okay, so this linear stack of layers can be easily represented by a API which we call sequential API. And what exactly it means? So I mean, to understand this, let's try to create a sequential API and let's see how we can do this. So just to understand this, I have, right now here kept a very simple piece of code, and let's go through this. So this is the three steps you can follow. For example, theoretically, what is this? I mean, the steps of creating a sequential model that initializes an empty sequential model. Fine. So basically, remember one thing, that Python is basically an object oriented programming language, right? Just like Java. So that means here also we will, you know, when we want to work with that, we will do with respect to creating an object. Okay. So initialize an empty sequential model means creating an object, having nothing over there. Okay, something like that. Then add layers one by one using dot add function. And this is what I was saying. Like there is a function dot add, and if you pass the required parameters here, the function will itself add some layers, create probable set of weight matrix for you, and you don't need to work explicitly creating those things. Okay, and then these layers are connected sequentially. Sequentially means layer 1 will be connected with layer 2, layer 2 with layer 3, and something like that. Okay, and as an example, the piece of code given something like this, where if you want to create sequential model, remember you have to use a specific function called sequential, and this function is present within the Keras.models part. And that's why you see I have written here from Keras.models import sequential. Remember, if you write only from Keras import sequential, you will get error, because sequential function is not present directly in Keras package. It is present under models folder of Keras package. So you can assume that these two are basically folders. Assume that in this way. So within their Keras is a folder which presents everything. Within the folder of Keras, there are many other folders present. Okay, one of the folder name is models. Within this models folder, there is a function sequential. If you want to implement that, if you want to utilize this function, you have to import it from where? From keras.models. Similarly, this sequential function will create the first step, that is initialize an empty sequential model. Okay. Now what you have to do, as I told you, that we can utilize the add function on the object of the model. Okay, so that's why you see here I've written model equal to sequential. It's just like a creating an object of sequential class. Okay, and in this sequential class, so it's basically creates some empty model. Now in this empty model, we have to connect the layers one by one, right? And that is why we can call add function of the with this model. So that's why I have model dot add. Now within this add function, definitely I have to pass some parameters. What are the parameters? The parameters should be represented within another function which is dense. So you see, dense is a function which represents a fully connected layer. Okay, because we are going to create a multi-layered perceptron. If you can recall what multi-layered perceptron was and what basically how it looked like, if you just close your eyes and try to imagine, you will see that basically from layer 1, each and every neuron of layer 1 is connected with each and every neuron of layer 2, right? So just for example, the one particular neuron, just assume one particular neuron of layer 1 is connected with every neuron of layer 2, something like that, right? Similarly, another neuron of layer 1 is connected with all the other neurons of layer 2, something like that. And this basically creates is called this is basically we call fully connected. That's why it's called fully connected network. Each and every neuron is connected with each and every neuron of the next layer, right? And to create this fully connected network using Keras, okay, not from scratch, we can use a function called dense. That this function will create the layer. So, and that layer should be added in the model, right? That's why you see within model.add function, I have called this function dense. Okay. So, this dense function will return a dense layer, means all the neurons. Okay. And how many neurons will be there? That is represented by each and every parameters here. For example, you see in the first layer, I've written model.add within bracket dense. So this function is going to create the layer. Within bracket, it is given units equal to 64. That means in the first layer, there will be 64 neurons. Okay. I'm sorry. There is a mistake. It should not be 64. Definitely 64 neurons. Fine. Then activation value. What does it mean? It means that from each and every neuron, you know, the neurons are basically summing up the outputs coming from the previous layer, right? Right. And these previous layers summed up, then we have some activation function, right? We have seen, and that activation function, activates the output of the neuron to the next layer, something like that. That happens, if you can recall, right? So for every neuron, it's associated with some activation function. That activation function can be sigmoid, can be tan hyperbolic, can be ReLU, can be softmax, can be signum, can be linear, because a lot of activation function we have already seen in previous classes, right? So over here as an example, I have given activation equal to ReLU. Then it is given input underscore dim equal to 100. What does it mean? It means that the dimension of the input data is basically 100. So just assume a example that each and every example, the training data is represented by 100 dimensional vector. Just like, for example, if you can recall what we have done in last day in using iReach data, there was four features, right? Four features. So those four features should be the input of the first layer of the neuron, right? So that means every pattern or every data point is represented by four values. In other words, we can say that every data point is basically a four-dimensional vector, right? In the same way, here this input underscore dim equal to 100 means that each and every data point in the data set is a 100-dimensional vector. So that is the input one, and that should connect to the input layer, I mean to the next layer, something like that. So since for when we are adding the layer for the first time, we have to specify that what is the dimension of the input and what should be my I mean the out I mean what should be the layer in the you can say uh, in the model in the next layer. So what does it mean? I mean, let me try to draw a very in a very simple way. Just a minute. So something like that we have a 100-dimensional vector. Okay, so we have some value here, total 100 dimensions, and these connected with the neurons here, right? Remember, each and every point here is representing one neuron. but which is basically we call input layer neuron. If you closely watch, you will see that the input layer neuron does not have any activation function. The activation function starts from the next layer. So the activation function should be associated with this neuron. This neuron. That means neuron in the second layer. So what this particular first line is saying, that the input dimension is 100 and each and every, you know, neuron in the first layer is connected with each and every neuron of the next layer, like this, right? So this units 64, it means that 100 dimensional vector will be connected with the 64 neurons individually. So the, you can say, the number of hidden units in the second layer is 64. So that means in the first line of the model.add, we basically specify what is the number of neuron present in the, you can say, second layer of the multi-layer perceptron, not the first layer, because the first layer of the multi-layer perceptron is input layer, and that should be equal to the number of you can say the dimension of the data point. For example, over here the dimension of vector, the data point is 100. So that means the number of neuron in the input layer should be 100. Okay, that's I mean, you cannot change that, because according to the data set that you are provided, that's fixed. But what you can change? You can change the number of neurons in the next layer, or maybe next to next layer. So as many layers you will add, you can alter the number of neurons over there, but not in the input layer. So that's why it is fixed. Instead of writing 64, you can write here 164 or 264. Doesn't matter. I mean, doesn't matter means you can alter this, but you cannot alter this 100, because it is fixed. It is calculated based on the data set. Okay. And the activation equal to del V is written mean that the activation function associated with this layer means the second layer actually. Although I'm calling the modular function first time, but actually we are specifying it for the second layer. So the activation function associated with these neurons is a ReLU, not the first layer neuron. First layer neuron does not have any activation function because that's the input. So anyway, fine. Now I hope this is clear now. Now once this is done, so it's something like this. This is created. If you want to create more layers, as more layer you want to create, as more number of model.add you have to call. For example, over here, the second time model.add is called, so that means another layer will be created. That's for sure. Now in the another layer, how many neurons will be there? That will be defined within this dense function by this units value, which is given, so for example 10. That means in the next layer, maybe you will have, say for example, only 10 neurons. So 1 neuron, 2 neuron, and maybe like this we have 10 neurons, which are connected with this previous layer definitely. So the connections with this neuron to this neuron will be there via the activation function obviously, and also this one, and also this one, and also this one. Similarly from here to here, here to here, here to here, and for all the other neurons similarly. So now question is that where this weight matrix value, because this is some W, this is another W, this is another W. I'm just writing W here, but it's definitely not W. It should be some W1, W2 like that. Different connections represents different weights. So all these connections will have different weights and represented in some matrix. But I have not defined any matrix here. And that is the beauty, that you don't need to write any matrix, you don't need to define any matrix explicitly. Based on the model you are creating, by calling these functions, the matrix will be created automatically behind the scene. If you want, you can see what is the value of the in the matrix, that you can see, but you don't need to create explicitly. You are just calling functions and automatically the models are created. Okay, so in this way we can create the dense layers, which also we call fully connected layers, using this sequential model, and using sequential API, which we specifically call sequential models. And also in in other words, we also say as a multi-layer perceptron, because it's a multi-layer perceptron. We can see this, right? Now depends upon problem, depends upon the complexity of the problem, or maybe the different the different issue. Maybe we have to decide how many layers should be there in each and every layer, how many neuron you can put. That definitely will vary, depends upon the problem, depends person to person, the perception may vary. So that we can say for example do some research, that whether keeping 64 neuron is sufficient or not. Okay, there is no rule book that for this type of problem you have to have this amount of neuron in the second layer of the MLP. There is no such rule book present. Okay, so you have to check that which is the best combination of the number of neurons in different layers, for which you can get best result. Okay, so to some extent you can say that this MLP finding the best solution is a typically bit, you can say, a trial and error procedure. Not error, but finding various finding the accuracy with respect to different type of architecture. Okay, and take the best one from that. Or maybe you have some threshold. Say for example, you can say that the model is acceptable if it gives 90% accuracy. So if the model somehow comes with 90% accuracy with also other parameters correctly, then you can stop checking whether I have any more better model or not, something like that. Okay, so basically what the steps, in a nutshell, what we can say, that steps is basically steps for creating this type of neural network, or maybe multi-layer perceptron, whatever you say for time being, is that you have to define the model architecture. Okay, what does it mean? It means that you have to specify the number of layers and their types. Okay, so types means it is given here in bracket, you see dense, conv 2D, LSTM. What is this? This conv 2D LSTM is not yet we have explored. This is the part of deep learning architectures. So you don't need to worry about that part. Just assume only dense part. Dense is a function which creates a dense layer, fully connected layer, just we have seen. In the same way, we have conv 2D is another type of function which creates some different type of architecture, depends upon the problem that we will see in future. We don't need to You don't need to think about conf 2D, LSTM, etc. for now, as of now. So you can see only dense part. So we have specified the number of layers. So as more we will use model dot function, as more number of layers will be added. And within model dot add, depends upon the number of neurons that we want to implement in that particular layer. Within dense function you have to give the num units. I hope this is clear, right? It's very straightforward. There is nothing to think about it or research on this part. After this, the second step is, as written, compile the model. What does it mean? It means that I have said that okay, in my model I must have three, four layers. The first layer is the input layer, that is the number of dimension. For example, over here, input dim, by which I have said that my data set has say n dimensional vector, so input underscore dim will be n. Now in the second layer, maybe there are 50 neurons. So that means for the first line of model dot add under dense function, units will be equal to 50. Maybe in the next layer, that means in the third layer actually, maybe say there are 100 neurons. Okay, so in that case, in the second line, instead of units equal to 10, it should be 100. And maybe in the next layer, you want to say keep 10 neurons only. Okay, so in that case, units will be 10 in the third model dot add function, third line. In this way, we have created the layers and they are automatically connected now. Also, you have specified what should be the activation function in that layers for all the neurons. Okay, remember, I have specified the activation function equal to redo. It means that in this particular layer, for all these 64 neurons, the activation function will be ReLU. It is not possible that for some set of neurons we will have some activation function, some in the other set of neurons in the same layer we will have different set of activation function. It is not possible. In a particular layer, for all the neurons, you will have same activation function. Okay. Similarly, for some another layer, maybe activation function can be softmax. So it depends upon our choice. Okay. So in this way, I have done this. Now, the things that is still left is to decide what should be our loss function, what should be the optimizer, and what should be the evaluation metric. What does it mean? What is loss function? Loss function means, see, if you can recall the backpropagation algorithm, when we try to derive the equations of backpropagation algorithm, we said that we are using error based on a squared error, basically 1 by n summation over 0 to n yi minus yi cap whole square, right? What does it mean? Yi is the output, actual output, yi cap is the predicted output, their differences square added summation over 0 to n for all the outputs by 1 by n. So it's basically square error divided by n, something like that, average square error, right? So in during derivation of the backpropagation equation, my loss function was basically a average square error. In the same way, we can have many other different type of loss function available. Okay, so we will see those different type of loss functions, okay, in future. So that we have to specify what type of loss function based on which the backpropagation will be done, because definitely depends upon the loss function, the equations will vary, right? The learning algorithm will vary, the equations will vary, means there will be no change in the strategy remains same, but the equations will change, obviously, right? If you change the equation of error, automatically the derivations, the derivative of error with respect to weight will change, right? So that's why definitely the learning also will vary, right? So that's why you will see in future that for the same data set, for the same architecture, if you change the loss function, you will see your learning is affected. Okay, we will see that anyway. Then optimizer is what? Optimize. What does it mean? We are trying to optimize the error, right? So here optimizer actually helps to optimize the error and gets the best set of weights for which the model is sufficient good to good do a good prediction. So that is what the purpose of optimizer is. So there are again different type of optimizers available. We will see what are the different type of optimizers available in our in our hand, and we can also see that how we can use them. Okay. Similarly, the evolution metric means on the basis of what you are going to decide your model is good. Is it by simple difference between predicted output and target, or it is something different? So there again there are different evaluation metrics, so that also we have to decide. So with these three things mostly, and also creating the architecture as per our choice, we now have a model. We have not yet started training. Now we have to do the training. And that's why we again have a function. Just we have to call that. We're giving some specific parameters. And the function name is dot fit, as you can see here written. Dot fit. So this dot fit function is actually tries to fit the model on the data. Okay. So basically it will do it will train the model, as simple as that. In our words, you can say. Okay. During training the model, we can also specify the validation data, the validation set, just we have seen in last day. And also we can say the batch size. What does it mean? Here, this part is new, batch size. Batch size mean that, see, when we basically try to derive the back propagation algorithm or try to write the code from scratch, what we have seen, we have basically just giving the strategy of training the model is something like you are giving input, the first input, you are getting output, evaluating the error, based on the error the back propagation done, the model's weight are changed, then the second input fed. I mean, so the steps is like the first input become it basically called forward pass. The first data set, I mean, say for example there are 100 data points in the data set. The first data point is you can say forward passed to the model, error calculated, the error is back propagated, so it's a backward pass, weight updated. Now the second data point forward pass, like this. So for every data forward pass, we are running a back propagation algorithm, we are updating the weights. But sometimes it is much more efficient that don't update the weight immediately. Rather, what we can do, we can pass some n number of data at a time. Okay. So that means, just assume that you have a data set of 100 data points. Okay. That means 100 row. You have decided that I will pass the 10 data points, that means 10 rows, one by one. And for if the 10 row, definitely 10 times I will get the error. Error means the predicted minus actual output, right? So what we can do, for the first input, the first set of error I got, and I have stored that. For the second set of input, second set of error I have got again. Remember, when I am passing the second set of input, I have not back propagated. Okay, I have kept my error. So I am basically accumulating all the errors for the first 10 rows. The accumulated error, based on the accumulated error value, now the back propagation does. So that means instead of back propagating the error for only one input or fit for one forward pass, we are actually back propagating the error based on the cumulative error of the 10 forward pass. So basically what you can say, that the model is basically learned based on the 10 data points as a batch, and that is what we call batch size. Okay. So in future you will see that you will have a very large amount of data. Say for example 10,000 data points. So if you, for every data point, if you do the back propagation, which may not be effective and also time consuming. Instead that what you can do, we can say that okay, let's create a batch of, 10 batches. 10 batches means, it means that for every 100 set of input data, okay, we will backpropagate the cumulated error for 100 inputs, something like that. Okay, and sometimes this is very, effective in very large data set. So we will see that again. Okay, and after doing this training, obviously we have to evaluate the model with some predictive, right, with some predict function on the unknown data set, and that's why we call predict function. So you can easily understand this predict function is doing nothing, it's just predicting, it's not doing any back propagation. Now the model is trained, we this predict function means it's taking input only some test data and gives the output, that is what is the error, or maybe what is the accuracy, not error, with accuracy, how much accurate the model is, maybe 80%, maybe 30%, maybe 95%. So depends upon how good the model trained. So this is the whole story of, from starting of creating a model architecture, also giving all the optimizers and evaluation metrics based on which the model will get trained, training the model, predicting. It's a whole story like this. So is this clear now? What basically you are going to do? Hello. Okay. Very good. So any question? Okay. So basically, we have just went through the set of steps by which we can create the model and, you know train the model for my prediction, right? So you see the dense layer, conf 2D layer, LSTM layer, just what I have said in previous slide. See here a very small explanation is given. Although conf 2D layer or LSTM layer we are not going to explore for, you know time being, but just for a very simple knowledge, you can see here that dense layer, as I said, as already you have seen, for fully connected layers, specifically multi-layered perceptron, where each neuron is connected to every neuron in previous layer, just what we have implemented in few previous days. Conf 2D layer mostly used on image data. Okay, so it's not that always your data will be in some numerical values directly. Maybe your input can be image, or maybe your input can be text, A, B, C, D, something like that. Okay, so in those cases, conf 2D layer is used, and the idea of conf 2D layer, what exactly conf means and all everything and mathematics behind that, we will learn in very detail in future. Once we will get enough trained to work with dense layer, then only we can go to the conf 2D part. In the deep learning part. And LSTM is also a part of deep learning, as it is written long short term memory. It's again bit complicated for you right now, that what exactly long short term, where memory comes, and what is this. So again, that's why I'm not going in detail. Just for timing, you can see it's used for sequential data, for example time series data, or natural languages. For example, you can see that a very simple one I can say, like you are using in Google, there is a button you can press, and you can speak something in go something in your, in front of your phone, and you have something in your phone which basically captures what you are saying, and it converts to a particular text, and based on that the searching started. You have seen that already. You know this. Question is that who, I mean, see how intelligent the model is in your phone, that whatever you are speaking, the model is able to understand, and not only understand, model is able to interpret that what you are basically going to say. And one of the best example ever till date we have is ChatGPT, right? So whatever you say, you will get a constructive answer. So that means, the model is able to interact with you. So trained it is. Now, how it is possible? And for example, what does time series means? Time series means that right now you are saying something, giving some inputs. Next time, and based on that, the model is giving some answers to you, just like a chatbot. Based on that, maybe you have given some more input. Now, a model gives input. Model gives output to you based on not exactly what you have said now, but also the earlier inputs that you have given. So the model is able to capture or able to store or remember the informations that currently you have given and also you have given in past, right? How it is possible? How model is doing that? And how model is filtering that up to how much information the model should remember of the past and how much for the present? Here comes the memory. Here comes the concept of memory. Not only this given that long short term memory. That's why name. Okay. Anyway, so it's going to be very complicated if I just trying to explain this now, because we don't have very good idea on Nestle at that moment. Anyway, so we will see this in future.